it helps them get a handle on their efficiency and taking all that analysis and being able to drive change in the infrastructure. So guys, welcome.
Hi. Yeah, maybe some of you are still familiar with us. I presented there. Hopefully we go. There we go.
Here we go.
Yeah. So, show of hands, anyone has been here in 2019? A few of you guys. Okay. So, in 2019, we were here the first time with Deutsche Telekom Technik, presenting kind of our very first use case with NSO. We are a few years farther now, and kind of want to talk a bit about a new challenge we had and how we approached this, and hopefully you find some of the sustainability parts presented earlier in our approach. When we prepared the talk, we didn't really have sustainability in mind, but there are a lot of nice parallels, I think. Yeah, so let's dive in. Who are we? All of which you will see is a team effort, so we have a fresh picture from last week from our team offsite. We're just the two lucky guys who are here on site to be with you. So I'm Johannes, I'm with Deutsche Telekom for about 10 years. Been in planning, engineering, operations for data centers, and now for 5 years working on automation.
Hey. I'm Daniel Post. I'm a software engineer since about 20 years. Before I joined Telecom, I worked for financial industry, also did a POC with the NSO there in 2016, got in touch with NSO on Cisco Live in 2015 in Milan. So that was the acquisition from TLF to Cisco, and I got first in touch with it. And unfortunately, the contractor I worked for, the financial industry, didn't get NSO, but now Telecom has it, so I'm working here. Yeah, and what is going on? We are from Deutsche Telekom Technik, which is a subsidiary of Telekom Deutschland, and we are responsible for the whole Telekom Technik in Germany, fiber infrastructure, RAN, also the application for the IMS, everything related to provider technology is hosted with us. We had some analogy to Sweden and Spotify. We had a transition 2 years ago, and now we also have tribes, squads, and chapters like they did have at Spotify. So we are working now in the Outland team, which is a squad within data center infrastructure tribe, and we are responsible for automating our 150 classical service areas data center where we host all our applications or telecom applications. Okay, what is going on? For a few years, there's the idea around from folks within our tribe. There are discussions how to ease building new data centers. It is a very manual-driven task since now. The organization, the planning, the configuration, everything is done pretty by hand, and they wanted to just turn it around and set up a new project, which basically have over as a headline, bare metal for everything as a service, and then reduced it down to BMAX. BMAX is the project we are currently working in. What is BMAX all about? So basically, we want to fully automate data center provisioning. So we specified standardized data center layouts. So how does a data center look like? We have defined racks. We tell exactly on which location what rack is going, how many racks, of what size, of what type. So we have standardized compute, storage, and network hardware. We do not have a zoo anymore. We just buy 2 vendors and period. We have at the network side, we are planning for a multi-tenant EVPN-VXLAN spine leaf fabric network on all sites, which is already designed. And one of the primary drivers, which cost a lot of manual effort before, was the automated hardware ordering and commercial processing within Telecom. And one of the, do I have a pointer here? No. One of the most advanced features is that everything is consumptionable about a standardized API. So on top of our BMAX project, we have our internal cloud providers, the Kubernetes, the OpenStack, and the VMware folks. And when they now need new hardware for their virtualization or containerization platforms. They just choose or they just acquire hardware through our API. Yeah, and it's not the network, it's not only the network, it's also the automated provisioning for compute and the automated provisioning for storage, and everything has to go together. So how does that work? We have roughly these building blocks here. On top, we have the app, which is a Spring Boot application we are developing by our own. That is also one major goal. This is business critical. We do everything by our own. We do not have any contractors. We have a lot of software engineers currently working in that project. The BMAX app is more or less the orchestrator, which does the east-west traffic for the provisioning. So when planning is coming in, the app takes data, and we are using NetBox as our inventory management system. And also, we are having connections to the telecom business IT for ordering, purchasing, and whatever lifecycle management. At the enabler side, we also use Infoblox for IP management and for DNS. And we have Vault, for example, for credentials, security. We put all our passwords in. On southbound from the BMAX app, we have our provisioning stack. And what you see is we use our stack Johannes presented in 2019, which was Attentional up front and NSO in the back. And with NSO, we provision all data center fabrics. And for server and for storage, automated provisioning, we use Terraform and Lenovo xClarity. Numbers, we already bought around 4,500 compute nodes, 1,500 network devices, 24 storage systems, 720 racks in 2 locations in Germany. We will set up this hardware. So we have also geo-redundancy. Why did we do it? Currently, all cloud providers are running their own hardware, which is inefficient. So we have 3 times guys for the server, 3 times guys for the switches. We want to free these resources because, as from one hand, it's better. So one dedicated team for the hardware infrastructure makes more sense. We are in an ongoing cloudification program, and that's also where sustainability comes in. So thanks to the speaker before, Soraya, we are trying to bring everything onto container. We are having various programs like 5G Core, which will only be hosted on Kubernetes. And we have also the program Cloud Booster, which tries to move other applications which are currently running in the legacy data centers or in the classic data centers onto the make them cloud ready and run them on Kubernetes. That requires a lot of new hardware. And as I said, we had the manual process in place, time consuming, and with that automation, it really boosts, it helps to order the hardware, to bring it in place, to administer it, and run it. And what also is we have a separation of concerns. So we are now the hardware guys, the infrastructure guys, and on top we have the cloud, and it's more clear who is doing what here.
So where does our team come in now? You saw the architecture, so part of our team is working on the BMAX app, kind of the core business logic we have for this project, and then also, of course, we're working on the networking side. And our goal is basically, we want to develop the network controller for this fabric, and covering everything from ZTP, day 0, day 1, overlay, etc. So how does this look like? Or what were some of the requirements or goals we had? So as we said, the spine leaf architecture is based on EVPN-VXLAN, but one of the key points we try to emphasize is we don't want to just buy an ACI and that's it. Because from our experience in the past, we have a lot of specialized requirements on whatever goes on in a network. If you worked with telecom before, you might be familiar. And so we didn't really want to buy a ready-made controller, and we decided, okay, let's build this with our stack. And we also wanted to be vendor agnostic, so Daniel said, hey, we have reduced our vendors, but we want to have the option to just swap everything out. And I think in the Telekom Croatia talk yesterday, you heard a lot about, hey, it makes it a lot easier to swap out to a different vendor or hardware to migrate. Okay, what was the situation like when we started this whole thing? So there's an RFQ in process. We don't know which hardware is coming. We don't know the vendors. We know we don't have physical labs or anything. We don't have the network design, and this is also something another team is working on. So we get the final network design sometime after our RFQ, whatever. Yesterday we heard Eisenhower quote. Today I'll quote Hemingway, one of my favorite quotes. Any first draft is shit, basically. So our goal was, hey, if we need to kind of get experience working with this kind of new technology for us. We developed an NSO service before, but we didn't work with this kind of setup on Fabric before. So what we wanted to do is just get started somehow. And as we heard in the talk before, with containerization, we have a lot of options now. So what we did is we used ContainerLab. We're just building virtualized network topology based on some best practice guides on the internet and just got working. And I'll talk a bit about what is ContainerLab. It's a very cool tool. There's the URL, check it out. It provides a CLI, and also, yeah, we're not using the ContainerLab CLI directly, but it gives you the opportunity to just define a topology, define what devices do you want, how should the devices be connected, and then you can spin this topology up, and yeah, basically you are ready to go to start with your development. So some of the devices we started with is Cisco 9K runs on there. We can run Nexus 9000, VQFX. There's a lot of stuff supported, and if it's not supported out of the box, we'll talk a bit about that later, what you can do to kind of get that going. So how does this look for us? We are not brave enough to do a live demo, so we recorded something. What you see, we have a little make command, which is wrapping around ContainerLab for us. We can specify a topology. When it starts again, you will see I'm specifying the topology edge, which we will get into it later, why we have to spin up different topologies. And then what ContainerLab does for you, just starts all the different containers for the devices, and then creates the virtual vias between them. And then you wait half an hour for an XR V9K to come up, because it's super slow. If anyone has any ideas how to speed that up and how to not have it consume 100% of your CPU, talk to us. Yeah, XRD was a recommendation we got. I'm also talking about that later, so we will see what happened when we tried that. But yeah, so that was one of the first things. Okay, how can we get started? So we also developed for these kind of network services for quite a while now, and we wanted to start a bit different this time because we are in a very different situation. So far we developed for brownfield. All the config was in place. We had very nice design documents that covered the regular cases in the network, as you already heard. Okay, you can't assume everything is configured to that, but yeah. So we knew there would be a lot of changing requirements as the design work goes on. So we wanted the ability to just be able to refactor large amounts of code and still know kind of what is going on, and also to kind of explain what is going on to the guys doing the network design, to kind of visualize what is going on, kind of be able to report progress. We are developing our NSO service with Python, so we decided on settling with behavior-driven development with Python and Behave, and Daniel will show a little bit more about that. It's basically our way to try to, yeah, kind of have documentation about our services that people can understand. And yeah, as I said, Daniel will show that. Okay, then you saw our team. So we have a lot of people, and basically, we want them to not step on each other's feet. So if you're developing on a lot of different services around the whole life cycle of a fabric, ZTP, day 0, day 1, day 2, you have a lot of parallel work. So yeah, everyone needs to be able to work on their own. We also kind of need to be able to check on whatever the other people are working on, to run that stuff on ourselves. And we also want to test our changes without breaking other people's stuff. So what we came up with is every developer gets a dedicated environment. Everyone gets his personal VM, as we heard before. And then on that VM, we do all the containerization that the developer needs. And it's very comfortable to just spin up with one command. It's very easy to onboard new people. So we also grew a lot in that time period to kind of support this effort. And what we also have is we have kind of a mono repository. So when you just switch your branch, let's actually skip to the next slide. This is how it looks. So you have your Git repo on the left. And whenever you switch your branch, we just have an rsync running, basically transporting all your changes to the NSO container. And all you have to do is do a package reload or a redeploy, depending on what kind of changes you did. At the start, we automated that, but was not a great idea, because if NSO always starts reloading, if you press Ctrl-S in your editor, sometimes you don't want that. So yeah, that's a manual step right now. We can also then, on this VM, run our Python behave code, so our test code, and then we see, okay, we have on the right the different lab setups we have. So we have NetSim lab, we have a container lab with different topologies. And what's not depicted here, we also have access to our physical test lab. And yeah, we basically work with remote SSH. Most of the people are using VS Code. There are some brave PyCharm and Vim warriors, but yeah, they're slowly phasing out. So how does this look? Again, small recording. So we have our container deploy. These are all the IP addresses for the NetSims we have. So for each NetSim, we spin up a container also. Then yeah, we have the behave container, so we also can use the same stuff for running the tests in our CI. We have all the iTential and NSO stuff. And yeah, then you wait 6 minutes roughly for NSO to get all the packages and do a package reload, and then you're ready to go. And ideally, you start both of these labs before you get your morning coffee, and then after that, you can start to work. So I'll hand over to Daniel to explain a bit more about behavior-driven development.
Yeah, thank you, Johannes. So as we already have seen, we decided to go for the behavior-driven development approach. As various advantages. So it's just clean written text. And what I brought you here is just a little example of one of our feature files. So Behave basically goes in there, interprets that feature file, and maps that in the back to the Behave code. We will see later a little code snippet of one of the step implementations. So behavior-driven, or the Behave, is using the Gherkin syntax, which has the feature background, given scenario, when, and then steps. And it's basically formulating one scenario. And then we see, okay, we have the when condition, so an action happens. I add a service connect leaf to fabric for device with the name. And that basically says everything. So we are applying a service with name connect leaf to fabric, that's the name of the service with an NSO, to that device with that ID. Ideally, so you also can apply that service to multiple devices. So you can, that is a table actually, the device you can have 1 or 3 or 10 host names in that table then, and you will apply the service to all of them then. So when you apply that service, it takes a while because everything has to be enabled. What we do here is, as Johannes showed our infrastructure, we apply that to our container lab devices. So and the code there is really going to action. So within container lab, we can verify even the operational function of what we do. So to get that config running or be activated OSPF protocol coming up, whatever timer are running, whatever is needed. We have to wait for a circuit time, so we have that step waiting in place. And once that is through, we first do a configurational check with that first then step. Then we are asking that device, looking into the CDB, if that IP address is really assigned to that interface. It's just a formulation, and in the back, in the code, we just do an NSO call and ask under device's device, under interfaces, if that IP is on that interface in unit 0, because that is a Juniper device here in this case. Once that configurational check passes on the BDD, we will do an operational check. Then we will ask NSO to initiate a ping from that device, from that interface, or from one source IP to that destination IP. And once the ping is successful, we will expecting successful. If not successful, that test will fail. So it gives us here, with BDD, a clear structure. Everybody can read it. I think everyone can understand it, so raise a hand who can understand that code here. Thank you. So we can even have a discussion with our network engineering guys, and they know, as they obviously see what's going on. And that's good for communication. Also, that is a documentation. Okay, what services do we have? When do we have that to run this service? With all our feature files, we can prove what we have developed in small increments, and we can show what the code is doing actually without digging into the code or looking into the young models or looking into the Python code we have. Okay. When we look at the when I add a service connect leave to Fabric 4, how is that implemented? So we are going into the Python. These are the step files within the Behave framework, and you can annotate the step with that annotation above that function, and then you will get passed in that context variable of the function, and within that context variable, there's a table inside where the list of devices or the device is in. So what we do, we have some services here, and we go into that, we iterate over that context table, we pull out that row, get the device name, and create an object of it, and call that object a REST call to provision that service. And we do everything over the REST-conf API. The whole testing is running against the REST-conf API in NSO. Also the operational tasks we do. And once that REST-conf call is successful, we are expecting an HTTP code created. Otherwise, we will respond the error code, and the test will fail. Okay, that is a little breakthrough into the behavior-driven development, how we do it. And that is a BDD demo. Unfortunately, that took quite a time, and therefore we just cut off a little bit. But you can see here, we do also a BGP neighbor test, for example. These are now all operational checks, and that is in real time, and we do ping all the infrastructure, and we try to ping within our container lab all the different passes which are established via OSPF, and we try to ping the opposite side if that is working, if our configuration is right, and we also do here a BGP neighbor check, so we have leave BGP connections to our DC gateway, and once they are successful, everything is good. So, and green is our favorite color here.
Which might be intentional, maybe not. But yeah. Okay, so that's the whole idea. It looks super pretty, but you also run into challenges a lot, and maybe some of the stuff you saw in the feature file will go into a bit more detail now. So one of the things is you want to kind of avoid having side effects in your services. So imagine you provision a service, you provision another service, you delete this one. Are you really sure that then afterwards you test, does your service actually cover the whole configuration? So what we try to do is always kind of go from a clean state. So at the right, you see again this given step, so given site And you have a few options there, and also, which is not here, our physical lab is an option there. So Containerlabs 0 is this kind of edge topology. Containerlabs 1 is kind of the core, and we have some resource problems. We can't start actually the whole fabric thing on one VM. It just doesn't work. So the edge topology and our development setup is 66 gigs of MEM already. So yeah. So we kind of went the way, okay, we have, depending on what kind of service you are testing, at least during development, you can kind of choose the site with a kind of limited setup. And then you also choose, okay, in which phase am I in provisioning? So day 0 is basically, okay, NSO knows about the device. The device has been cleared basically of all configuration, which is not related to just NSO reachability. Day 1 means, okay, we are ready with kind of our management setup. We are ready to configure underlay. And then day 2 is basically, okay, we are ready for overlay. These are the kind of 3 stages every single test will start with. And what we do to move between these stages during tests, so whenever you run a Behave feature file, it will, before we start the next scenario, just go back to whatever stage we have defined here. We're using the NSO rollback points to do that. So we just save, hey, after we brought the environment into day 1, this is the rollback point. After every test, we just go back there, which is what you see in the bottom. Okay, so yeah, availability of containerized devices. We already heard the suggestion with the XRD. It might work better for us than the XRV9K, which we put into a container. So containerized images are not always available for what you will work with. And maybe your containerized images, and that's where the XRD is for us, is maybe not compatible with your required feature set or container lab. In the XRD case, we have the problem, if we only use the management plate part, we can't really do our operational checks. So there's no layer 2 in there. And the other mode the XRD runs, the interface types used are not supported in ContainerLab right now. So yeah, we are kind of looking into that, how we can get that to work. So if you want to do this, talk to your vendors. Kind of tease out whatever they can give you. Some of them don't provide them officially, but unofficially. You have to be careful with kind of licensing there. To kind of to comply with your requirements, and then also you can use software like VRNetLab. Thanks, Christian, if he's in the room, for his contributions there. And we took a lot of what they used to do in the TerraStream project there. You can package, if you have a VM packet or VM image, you can just package it with VRNetLab into a container and then use it in ContainerLab. So the next part, you have different feature sets between virtualized devices and the hardware. So in our case, some commands might not be supported at all, which you see kind of in the bottom right. So we can't configure some crypto config we need on our virtual CSR router to simulate iOS devices. So we had to go the route to kind of, which we don't really like to do, and we shouldn't do much, to kind of put when statements, okay, look at the platform, and maybe if we are testing right now, don't configure this, and then once we get to the physical devices, okay, we can apply that config. Or other things, differing supported parameters. So for example, we want to run in our OSPF 3 times 50 milliseconds for the keep alive and BFD. The virtual devices kind of don't support that, so we have to kind of keep different global, let's say, configurations depending on which environment we are testing against. We just adjust these kind of timers in a central part. And then again, you have to kind of do some trade-offs. You can't really be certain until you went to physical devices that everything is actually working as expected. And then you might have different OS versions just available, newer software. You have special builds which might not be provided by the vendor. Then there's also kind of long-running setup times. So the day, given some site is provisioned to day 2, roughly takes 6 to 7 minutes for us. And if you're a developer who's right now working on a test and kind of expanding it, you don't want to wait 6 or 7 minutes every time you run this. So what we did is we kind of created a new tag, and we are exposing this rollback point that Behave doesn't really save across runs. And you as a developer can say, okay, I know I provisioned this before. I'll just tag my case and I'll save this time during the setup. So this is, using this tags roughly on a big test case speeds up the process for about 6 times. So a lot of time saving. And what we also did, if you're very, very sure you don't need operational checks, you're just working on a configuration template, maybe just use the NetSim topology. We also don't like to do that because we have some nets which are not super mature. Shout out to the 14S CLI net guys who are supporting us a lot right now with a lot of new tickets all the time. So NetSim is basically if you want to be very quick and save some time, but not really what we want to do. So then we need to go back to real devices to actually be sure, okay, everything is working. And kind of also going back to sustainability, we don't have our own lab for the network automation team, and then for the app team, and then for the network design team. So we have a shared environment, and we need to kind of manage that. And we also have a lot of good test cases from our network engineering team, and we kind of want to link all of that. So what we do, or some of that stuff is aspirational, but let's assume we are doing it. So we have nightly CI runs against this virtual environment to just make sure, okay, our branches are stable. We want to have mandatory CI runs against production or against the physical devices before we go into production with any use case. And then we also want to combine our test cases that you saw with the test cases that the network engineering team is doing. So they have load generators, they have a physical layer 1 switch to just simulate, hey, this link is failing, this link is failing, kind of seeing what we are configuring is actually matching exactly what the design intends. And what we use also for the app, it's a very simple locking mechanism there. Basically, it just has the option, hey, I want to reserve an environment, I'm this user and for this time, and that's it. And I can release that lock after some while. And then some organizational stuff. So you saw in the initial picture, there's a big architecture. We have a lot of different teams working hand in hand there. So network design, we have the automation team, we have the app team, we have compute, storage. All of this kind of has to work together. So at the end of the day, Kubernetes guys can say, hey, via API, I want compute, I want storage. So we kind of sync that up with the 4-week iterations right now. And then we have a lot of workshops kind of to keep that all aligned. We have some knowledge sharing sessions where we kind of have dependency. Hey, if the guys in Netbox introduce a new device role, what does that mean for us in the configuration? What do we have to change? These kind of things. And we are tracking those dependency in your favorite agile tool. So, status and conclusion. How far did we get actually? So right now we have our first cloud customer onboarded on our test environment. The first Kubernetes clusters are running. Not everything in the app or in the overview picture you saw is fully working. We are planning to have that exactly. We're planning to have that completed until the end of June. So it's working, and kind of going back to sustainability, we're working a lot with virtual stuff just to save the kind of lab resources that might consume a lot of power. And once we got all the kinks out, then we are moving on to kind of the life cycle and hopefully power saving use cases you saw earlier. And maybe to summarize what this did for our development process, so we have a lot of shorter iteration times for each developer. So we get kind of higher utilization, and by that can implement our services faster, which is always great. So that's what we have.
Thank you.
Are there any questions?
Thanks, guys. So from a product perspective, it's satisfying to see what you guys have done with NSO. It's great to see you use everything that the tools we have, but also you keep us on our toes and keep pushing us. So that is pretty cool. A question for me. So you stated your original goal for BMAX 4. How do you feel you are against that? Are you pretty good focusing more on application use cases now? Is there still more building that you need to do?
So what's great about this approach we have is everything will be 100% configured via NSO. So all the test environments are already 100% under NSO. All the ordering process stuff works. That no one ordered a server for this. It's all done automatically. All the build out, we have automated cable checking in the network, which is not to be underestimated. It's a good use case. If you ever had to find wrong cabling. So we are very, very happy with our progress. And we had some delays, but yeah, as we said, hopefully in June we can then move on to more kind of life cycle and other use cases.
Okay, very cool. So unfortunately, we're a little tight on time, so I know there are a couple of questions in Slido. We'll handle them offline. But thank you for the session. It was super helpful.